Hello guys, welcome back. So here we have another question on network theory from GATE 2016. In the circuit shown below, the supply voltage is 10 sine 1000 t volts. The peak value of the steady state current through the 1 ohm resistor in amperes is dash. So they are asking the peak value of current here, whatever it is. Let's call it I1. And the input voltage source is 10 sine 1000 t. So your omega is equal to 1000 radians per second. And here if you see, you have two LC circuit elements, right? And if you observe, the L into C value are same. And if they are equal to the resonant frequency being omega equal to 1000 radian per second, so these two will go away and the circuit is simplified. So let us check that. So what is LC here? 250 micro into 4 millihenry. So this is nothing but 250 into 4 is 1000. 1000 into 10 power minus 9. So it is 10 power minus 12. Sorry, 6, right? So what is omega resonant? It is 1 by root LC. So which is equal to 1 by root of 10 power minus 6. So which is nothing but 10 power minus 3 and hence 10 power 3 radian per second. So this is nothing but your omega R, the resonant frequency. So at resonant frequency, what happens? Your ZL impedance of due to the inductance is equal to your ZC, the impedance due to your capacitor. And now the equivalent impedance, Z equivalent is parallel of these, right? So now you have ZL in parallel with ZC. So what is the effective impedance? Z equivalent. So Z equivalent is ZL into ZC by ZL plus ZC, right? So they are equal in terms of magnitude. Your omega L is equal to 1 by omega C. But the ZL itself is j omega L and ZC is 1 by j omega C. So this is nothing but j omega L and this is minus j by omega C. So effectively ZL is equal to minus ZC when you also take the phase into account. So then what does this become? You will have ZL into ZC by ZL minus of ZL. So it is some finite term by 0. So which is equal to infinity. So this becomes like a open circuit. So similarly, if they are in series, ZL and ZC, they cancel each other out and Z equivalent will be equal to 0, which means it is short circuit. So if they are in parallel, they become open circuit, and if they are in series, they become short circuit. Okay, so we got that. Now let us find the current across the 1 ohm resistor. So for this 2 farad and 500 milli also the LC is same. So their resonant frequency also is same. So they will also become open circuit. So these two are open now. So now where the current will flow? It should flow here, flow here, flow here, flow through this 1 ohm and come back through this 5 ohm. Right? So this is your I. Your I is equal to I1 here. And what is your I1? Is equal to I is equal to 10 sine 1000 t by 10 ohms. So it is just sine 1000 t. And in the question they are asking for the peak value of the steady state current through the 1 ohm resistor. So this is the steady state current. What is the peak value? I1 peak is equal to 1. So it is the maximum of this. So it is equal to 1 ampere. So your answer is 1.